Welcome back to this webinar in the TechTalk webinar series that I'm running. This time, I'm very excited to bring you developing serverless applications with IBM Bluemix. So if you have attended my previous session, you would have noticed that I covered the basics of OpenWhisk. In this webinar, we'll go to some of the advanced scenarios based on the commercial implementation of Apache OpenWhisk, which is called IBM Cloud Functions. So I'm going to get started with a quick recap of what is serverless computing, and then I will introduce IBM Cloud Functions, and we will go through the basics of creating actions, triggers, and rules. So even if you are attending this for the first time and you have no background of OpenWhisk, you would still find this webinar relevant because I'm going to do a quick recap of the core concepts related to OpenWhisk. Once we are done with the basics, I'm going to take a closer look at packages, and we'll explore some of the available packages as a part of the Bluemix platform as a service, followed by understanding sequences, where we chain multiple actions to create what is called as a sequence action. And finally, I'm very excited to bring you an end-to-end serverless application where we will connect the dots between the NoSQL database of IBM Bluemix, which is CloudEnd, and IBM Cloud Functions. So this is going to be a real-world scenario that articulates how you can leverage serverless environment for sending out notifications or raising alerts when data in a database gets changed. So let's get started. So serverless computing is primarily an emphasis on code snippets than servers or platforms. Most of you are familiar with IaaS, which is infrastructure as a service, or PaaS, which is platform as a service. And recently we also saw the emergence of CaaS, which is containers as a service. But all of them require some kind of code plus configuration. In IaaS, you have to spin up servers. In PaaS, you have to create a runtime environment and then push your code to it. And in containers as a service, you have to provision a VM or a cluster and then deploy your containers to that. Serverless computing, which is also called as FaaS or functions as a service, is a very different take on running code in the cloud. Here you would actually take a code snippet, which is formatted as a function, and like any function, it typically takes some parameters, optionally returns an output, and then we deploy it in the cloud environment as a unit. So instead of spinning up VMs or deploying larger applications that run as a part of the PaaS environment or deploying containers, we now deal with functions, which are very fine-grained code snippets. And when we assemble multiple such functions, we'll end up creating more meaningful, complex applications. And this is going to be the foundation for the microservices paradigm. So let me do a quick recap of what is OpenWhisk. So OpenWhisk was originally developed at IBM. It was a part of Bluemix, and that was one of the early serverless implementations. Eventually, IBM and Adobe partnered, and they donated the source code of OpenWhisk to Apache, which has become an incubation project at Apache, which is called Apache OpenWhisk. So it is one of the mature open source FaaS projects available in the market. Companies like Red Hat and of course Adobe and some of the other market leaders are embracing OpenWhisk as their preferred serverless platform. So we are going to see adoption of OpenWhisk in the future because of the backing from the community as well as some of the industry leaders. Since IBM is the original contributor and the founder of OpenWhisk, it is the first one to make OpenWhisk commercially available in Bluemix, and that is called IBM Cloud Functions. So Cloud Functions is primarily a commercial version or a commercial implementation of Apache OpenWhisk. Obviously, it is integrated with rest of the services on Bluemix, like the weather information, CloudEnd database, Watson APIs, and so on. But the best thing about OpenWhisk is it is available to anyone, any platform vendor or any developer to very quickly integrate serverless environment with their applications. And IBM is currently the only one which is providing the commercial implementation, and that also acts as a reference architecture for deploying and integrating OpenWhisk with rest of the applications. So OpenWhisk primarily runs functions in response to events, and these events can come from web or mobile apps or even IoT apps. Anything that is capable of generating an event can be integrated with OpenWhisk. So the functions can also be directly invoked via HTTP. So it is possible for you to expose the functions that you are writing directly on the web, or you can also put them behind an API gateway and expose them like any other REST endpoints. And those endpoints, when called together or in a specific sequence, will form more meaningful interaction and workflow and becomes an integral part of an application. So the code that you deploy as a function in OpenWhisk can be executed in response to a synchronous HTTP call or a database state change. For example, CRUD operations performed to a database can trigger the code that you have deployed in OpenWhisk. You can also easily integrate it with open source object storage environments. For example, Minio. It's very easy for you to integrate the webhooks of Minio with OpenWhisk. So every time a file is uploaded to object storage, you can trigger an OpenWhisk function that can, for example, format it into a PDF or change the resolution of an image, and can do a variety of things. You can also integrate this with many other event triggers, particularly from the IoT, web, and mobile scenarios. So this is the high-level architecture, and we're going to take a closer look at each of these. Primarily, OpenWhisk is a platform that is exposing a set of APIs. And these APIs can be invoked from UI. For example, Bluemix dashboard can be used to interact with the OpenWhisk environment, or there is a very powerful CLI that can be used to manage the workflow of your functions or the life cycle of your functions. That is the administrative side of OpenWhisk. On the left, you're actually seeing what are called as packages, and these packages sit very close to the origin of the data or the origin of the events. So those events will be triggered, or basically they fire a trigger, and that trigger will in turn invoke multiple actions, and those actions will result in an outcome, which could include invoking a third-party service. So these concepts will become very clear towards the end of this session, but at a high level, I want you to remember the concepts of trigger, actions, and rules. So let's understand this a little more clearer. So when you actually deploy applications in OpenWhisk, you will only need to understand and deal with three different pillars. They are basically the foundational aspects of OpenWhisk. The first one is called as the trigger. The second one is called action. The third one is a rule. Action directly maps to the function that you're going to write, and that is completely independent of anything else. So you can create multiple actions that just exist independently and autonomously. These actions are going to be invoked by a trigger, and a trigger can invoke multiple actions. But how does a trigger know what action it should invoke? So there is a rule that comes in between the trigger and action, associating multiple actions with one or more triggers. So a data source like a database or an IoT sensor will directly fire the trigger, and the trigger will go to the rule, and the rule will figure out what are the actions associated, and it gets invoked in a specific sequence. So that is how we will end up wiring the actions with event sources via triggers. So this becomes very, very clear when we see a demo. So let me show you a very quick demo. So here is Bluemix. You can sign up for Bluemix without any commitment. It's a pay-as-you-go environment. And once you have the valid account, you can get started with most of the services. Cloud Functions, which is available as a part of Bluemix, is a part of the free tier, which means you can create up to a certain limit in terms of creating actions and invoking them. So when you click on catalog, you will notice there are a lot of services that are available, and there you can actually find functions. And here we have IBM Cloud Functions, which is nothing but a commercial implementation of OpenWhisk. So it supports multiple runtimes. For example, you can write your functions in Node.js, in Swift, Java, PHP, Python. And if you have legacy code that you would want to integrate with Cloud Functions, you can always package it as a Docker container. The event providers, which can effectively fire a trigger, include GitHub CloudEnt, which is the NoSQL database, IBM Message Hub, which is a managed Kafka, and Mobile Push, which is meant for push notifications. And you can also schedule a cron job through the periodic alarm. So this is the IDE where you can actually start developing your functions. So if you don't want to deal with CLI, this is actually a web-based IDE for you to create your functions. So as you notice, this is currently showing us a Node.js action. You can create either with parameters or with no parameters. You can also create sequences, rules. So pretty much everything that you can do from CLI, most of that can be done from the IDE. But we are not going to use this. I want to show you how to use the command line. So here, it has already created some. So let me get rid of it and get started with a blank slate, because I want to show you everything from the command line, which is very powerful. But you get an idea on how to use the IDE for getting started. All right. So here I am, and I want to create the very first action. So let me open my demo script. So once you install the Bluemix CLI, it is pretty straightforward. Just refer to the Bluemix documentation to install and configure your Bluemix CLI. So currently I'm using this to target the US South endpoint. So it is very clear, and this is my organization, and this is the space, which represents some kind of an isolation. For example, you can create multiple spaces for dev, test, staging, QA, and production. And the functions that you create, or the applications that you create, will be provisioned in one of these spaces. So currently this is my configuration, and I've already gone ahead and installed the Cloud Functions plugin. So this is the Cloud Functions plugin, which will give us access to the tool called BXWSK. So this is the tool that we are going to use to manage the lifecycle of functions and deploy applications. So this is a quick recap of the previous session, but I want to make sure that all of us are on the same page. So I'm going to show you this. So this is a very simple Node.js function. If you pass a parameter called name, it will embed that. Otherwise, it will initialize that with world. So that's what it basically means. So we are going to now create this function as an action in Cloud Functions, and then we'll go ahead and invoke that. So let me go ahead and create this function. So WSK action followed by create, the name of the action, and the JavaScript file. That's all we need to pass. And now this is going to create the function called hello. So it is currently supporting the Node.js 6 version. So it automatically detects and provisions your function to support that runtime. Once you have that, you can go ahead and invoke the function. So this invocation obviously returns hello world. If you want, you can also pass a parameter, which looks something like this. You can pass hyphen hyphen param followed by the parameter name. For example, in our function, it is name. So obviously we are sending that as the command line parameter here. And then world is replaced by the first name that I have sent. You can also use this without synchronous invocation. For example, you can also invoke it without the hyphen hyphen blocking and hyphen hyphen result, in which case it is going to be invoked asynchronously. So how do we see the output if it is invoked asynchronously? Well, you can basically list the activation. So whisk activation followed by list will show us a huge list of multiple activations, even from my previous sessions and previous demos. So this is the most recent one. So if I grab this and type whisk followed by activation result and the invocation ID, the activation ID, it basically shows the output. But this is very simple. This is not even using the rules and the triggers, because we are just creating an action. In the subsequent demos, we are going to create triggers and rules and associate them with the actions, so that when we fire a trigger, all the associated actions will automatically get invoked. I also want to show you one final thing. Let me delete the hello action and create it again with this new switch that says web is equal to true. And what it means is we are now going to get an endpoint that can be directly invoked from curl. So when I use curl followed by this endpoint, we can see the same output as the previous one. So this is how you can invoke web actions. But remember, it is not secured. There is no API key. There is no TLS. It is pretty straightforward, and at the same time, it is not very secure. So you got to be very cautious when you are publishing web actions. But you get an idea on how to use the command line and how to create your first action. In the subsequent demos, I'm going to show you how to create triggers, how to create rules, and even use sequences. So let's get back to the slide deck and walk you through the remaining concepts. So what is a package? Well, a package is actually a bundle that is associated with a set of actions. So each package contains what is called as an action and a feed. So these are the packages that Bluemix already supports. There are a set of predefined packages that make it just easy for us to integrate with existing services. So tomorrow, let's say you are creating a shopping cart and you want that to be integrated with OpenWhisk. So how do you expose the right level of events and create custom actions and create a set of OpenWhisk entities that are associated with your shopping cart? So you will actually create what is called as a package. And the package comes with set of predefined actions and feeds. And the feed is nothing but the event source, which will make it easy for us to bind at a later point. So you can create custom packages and expose them for developers to consume. IBM Cloud Functions include many predefined packages, right? So if you actually type this command, which is whisk package list followed by whisk.system, which is the namespace, you will see that there are multiple packages that are already available. The most interesting is CloudEnt, which is a database, and this database is going to be associated with OpenWhisk. So every time there is a CRUD operation that gets performed, we can automatically invoke an action or fire a trigger. Similarly, weather. So you can directly invoke certain weather actions by passing the long lat. I'm going to show you a demo of that. So these are called the packages, and you can create your custom packages as well. So let's take a look at the weather package. Is very interesting. So let me go to the next demo. Okay, so let's start by looking at what's available for us as part of the predefined packages. So this is going to show us what we have seen in this slide, and we are going to focus on the weather. So how do you explore what exactly the weather package offers? Well, you can run this command, which is package get summary followed by the namespace, which is whisk.system, and the weather package. So this is going to show us what this package supports. So obviously this is actually supporting two actions because it is highlighting it is an action, and this action takes parameters like language, lat, long, password for your service, time period, unit. So basically this is to get the weather insights for 10 days. And you can also get the pollen information by sending the API key that is created when you provision the weather.com service, the lat and longitude of the location. So currently, when we type WSK package list, there is nothing because we haven't provisioned any service. So what I'm going to do now is to actually provision the weather insights service. So this is a part of Bluemix service. So if you are a developer and you want to use the weather.com or the weather information, you can create that as a Cloud Foundry service and start invoking the APIs and embed that in your application. So it's also available through the dashboard. For example, when you go to the catalog and search for weather, you can see the weather company data here. So you can click on this and then create a service. So this is basically the available service. You can give a name to it, click on create, and this is going to create a service that can be used to extract the weather data. So what I'm going to do now is to use the CLI to do the same thing. So we are creating a new service instance of weather.com, which is going to be called as my weather. So it's going to take a few seconds, and very soon when we go to the dashboard, so if I come back here and click on the dashboard, we should notice that there is going to be a new service which will be called my weather. So we just use the CLI to go ahead and create this service instance called my weather, which is nothing but an instance of this service called weather insights. Now, to talk to this service, we need to create a pair of credentials. So these credentials will be used by the applications that are consuming the service. So let's go ahead and create the credentials. So this is going to be now creating a service key called my app, and that will be used to talk to this service called my weather. So basically this is nothing but a username and password that we are creating for the service instance called my weather. So now when we come back and click on this, when you click on my weather, it should show us the credentials that we just created. So select service credentials here, and there we go. So there is my app. So here, if you look at view credentials, this is exactly what we created: a username, a password, and a URL. So now when we refresh the OpenWhisk packages, it will automatically detect that we created a weather service. So Bluemix underscore my weather underscore my app. So this is the binding that is just created. And now when we do a package list, we'll notice that we have a new package available to us to consume. This is basically pointing to the same weather instance that we created called my weather. Perfect. So now we have the service, and let's go ahead and invoke one of the actions. So this action is a pretty interesting one. So I'm invoking an action called forecast, and this forecast is going to take a few parameters like latitude, longitude, and the time period, which is current. I'm also using a command line tool called JQ, which makes it very easy for us to look at the JSON output. So when I execute this, I'm going to get the forecast for Hyderabad weather, which is very accurate. So this is basically the information that the weather package returns when we execute this action. So let's find out. So it is showing us Hyderabad Rajiv Gandhi International Airport. That is the standard name. And then it will tell us details like visibility, the UV index, the UV description, the current temperature, and so on. So the forecast is mostly cloudy. So this is how you can basically use a serverless operation to extract the weather data. So this is a part of the weather package, which is very powerful. So just like the weather package, there are many other that we can look at. For example, if you run this command again, now you'll be able to relate better. So there is messaging for push notifications and so on. There is utils. We're going to explore that in the next demo. For Watson, there are a couple of packages for translator and speech to text, text to speech, and so on. There is also one for GitHub. Once you configure this, every time you commit code, you can invoke a serverless operation running within Cloud Functions. So it's a very powerful mechanism to bring new data sources and new event sources that can be used within the environment. Perfect. So let me now take you back to the slide deck and introduce the next concept, which is called sequences. So sequences are basically chaining multiple actions, and this very closely resembles Unix pipes. For example, in Unix, or for that matter in Linux or any star mix environment, if you want to find the number of lines, you can always type a command, pipe it to wc-l, and that's going to show us what is the line count of the specific command. So we can chain multiple commands together, and they are called the pipes. So most common pipes are used along with grep, with sed, and so on, find, and so on. Now, the most interesting thing is when you have multiple actions as a part of the OpenWhisk or Cloud Functions environment, you can create a sequence, and this sequence will help you daisy chain multiple actions. For example, A1 is an action that is going to throw an output. That output is fed as an input to A2, and the final output will be what A2 will return. So you can create a pipeline of actions by executing them in a sequence, and obviously this way of chaining multiple actions is called as a sequence. So let's explore how to create sequences in OpenWhisk and Cloud Functions. So I want to show you the next demo. So there is a package called utils, and this utils is very helpful for developers. It comes with many actions. For example, there is an action to get the current date time. There is an action to split a string into an array, and there is an action to sort an array. So all these are very specific to the developer operations that you typically perform when you are writing code or when you are deploying applications. So we're going to create an interesting sequence that will make use of two different actions. So there is an action called split. For example, when you invoke this, so whisk action invoke, we want the result immediately. So this is a synchronous invocation, and we are executing this action called split. And the payload is the quick brown fox jumps over the lazy dog. So when we actually run this, we are going to see an output that actually shows something like this. You know, it is splitting the 3 lines where there is a new line terminator. Now let's say I want to sort this. Okay, so if I want to sort it, I can invoke another function, another action called sort. But before that, I need to basically take the output of this command, right, and redirect it to a JSON file. Let's call it lines.json. So now when I execute, we don't see anything, and there is this new file that is created called lines.json, and that has exactly the same output that we have seen earlier. Now that I have the output from the split action, I can safely pass that into sort. So now when I run this action, when I invoke this action called sort, and I'm sending the parameters, parameter as a file, and this file has 3 different lines, the quick, brown fox, the entire thing is now split into 3 different lines. So now when I execute, it will take the JSON file from the disk, sends it to the action, and then that is going to print the sorted output from these lines. Okay, so there is not much change because it is already sorted, so you don't see a lot of details. So let's make this interesting. So now what I'm going to do is to basically create what is called as a sequence. Okay, and this sequence is nothing but yet another action. So we are now creating an action called sequence action, and we are passing this switch called sequence, and we are combining 2 different actions. One is split, that's the first one. The second one is sort. So when we invoke this action called sequence action, it is going to execute 2 actions in a serial order. First, it will execute split, takes the output, feeds that into sort. So let's go ahead and create this. Okay, so now when we, for example, execute this new action, which is nothing but a sequence action. So let's jumble this up a little bit. Okay, so here I'm going to get rid of D, because I want to see how this is going to get sorted, right? Now when we execute this, we are going to see a different output. Okay, and what this basically means is it is executing 2 different actions in a sequence. So it is taking the parameter. First, it passes to the split, which is now splitting that into an array based on the terminator, which is the new line character. And then it goes through sort, and we see the output as the sorted payload. So that is the advantage of stitching multiple actions together to create what is called as the sequence. So it's a pretty powerful mechanism to pipe the output of one action into another. This example could be very trivial, this could be very simple, but in real world you can basically pipe the output of one action to the other to create a very complex workflow, a very complex sequence of actions. For example, something comes out of the database and you want to send a push notification, so you can create a sequence action between the read action of cloud and database and a push notification action, and every time there is a change to the database, a push notification automatically gets sent. Maybe it's not a good idea because every CRUD operation to the database will result in a new push notification, but you get an idea. So that's how we'll create sequences. Excellent. Now we are equipped to deal with more realistic applications. So it's time for me to show you the grand finale of Cloud Functions. So it's a very interesting scenario which will combine all the concepts that we have discussed so far. So what I'm going to do here is to create an end-to-end scenario that covers 2 things. First thing, every time the database is updated, I want to every time there's a new record added to the database, I want to log that change. So maybe that goes into a different output and it gets logged. Apart from logging, I want to send out an email if the order value of the new sale is more than a specific value. So basically, we are dealing with an order system. So sales managers all over the country are closing the orders, closing the deals, and every time a deal is closed, a new entry gets added to our sales database with the manager name and the new order value. So if the order value is more than whatever we specify, then I want to send an email to the supervisor because it's a high value, high worth order, and I want the notification to go out. So this is a very classic scenario. For example, product managers are interested when a specific order gets placed related to their brand, or sales managers are very curious to know if a high value order has hit the system. So creating a notification for that is very practical and very realistic. So let's actually create an end-to-end serverless notification based on Cloud End database. So what is Cloud End? So if you come to the catalog, you can create what is called as the Cloud End database. And Cloud End is based on CouchDB. And this is a NoSQL database, which is completely managed by IBM Bluemix. So it is DB as a service, database as a service. So what we're going to do now is, from the command line, I'm going to create a database called SalesDB, right? So before that, let's see the package list, right? So the package list should show us the weather app from the previous demo. Let's leave that as it is. But I'm going to now create a new service called SalesDB, which is an instance of Cloud End NoSQL database. So this is going to take a minute because it has to provision an instance of Cloud End, which we are calling as SalesDB. So now, if you come back to the dashboard in Bluemix, you should see the new service instance for there we go. So now SalesDB is created. SalesDB is nothing but an instance of Cloud End DB as a service offering. Obviously, we need some credentials to talk to this because just the instance is not sufficient. So now we'll go ahead and create a credential for accessing this, and we are going to call this my app. So it is nothing but a username password combination that we are creating, and this is going to help us in sending out the notification. So if you actually see, it will be available here. So there are service credentials, and here is the service credential called my app that we just created. And it comes with a username, a password, and a complete URL that we're going to use for performing the CRUD operations on it. Excellent. So now it's time for us to get the same details from the command line. So it is getting us the service credentials. Okay, so this is the same thing that we have seen in the dashboard, right? So it's the same output. Now, the most interesting part is grabbing this URL. This URL has everything that we need to access the database. So what I'll do is I'll populate this variable called Cloud End that we are going to use because I don't want to deal with this long URL. So I'm going to put that in a environment variable. And then we will check if we can access this from curl. So when I do a HTTP GET, on this, it shows us some metadata. So it is a PaaS offering, it is running CouchDB engine, version is 2.0. Perfect. So that means the URL is working fine. So Now we are going to basically get the details of the cloud and database. So now I am calling this, it should show us the same output, but in a slightly formatted fashion, because we have the JQ, which is the nice command line JSON formatter. So everything is in place. You can also list all the databases that are available. So when you access this with -all DBs, obviously we haven't created any database, so it's empty. So let's go ahead and create a database in CloudEnd called sales. So when we actually run this, remember we are now putting a -x put here, which means we are now creating a database. So the put request of HTTP will end up creating a new database called sales. You can pretty much verify this here. So when you launch the dashboard of our CloudEnd instance, it shows the document collection under the sales container. So it should be visible here. So when you go to databases, there we go. This is sales. So there are no documents because this is just been created. So now what we'll do is we'll actually add a new row. Again, I'm using the REST API of CloudEnd. So I'm basically sending a JSON payload, and we are creating a new collection, a new record, new document with a key value pair, which is name Johnny. And we are doing a post. So when we run this, we'll end up creating a new record. So let me refresh, and there we go. So now we have successfully created this entry, right? So this is now created. Perfect. So now let's go ahead and get rid of this, because we just wanted to check if the record is created. So when I do an all docs, so it tells us that the record is created. So now I'm going to delete that because we don't want to leave this record. So how do I delete? It's pretty straightforward. We just need to grab the document ID, which is this, followed by the revision ID. So I'm going to grab this. So these are the identifiers of the row. So when I execute this, it will go ahead and delete the record. So when I do a refresh, obviously we are back to no documents. So we have gone ahead, created a new database instance, and we have created a new database called sales, and we tested if the REST API is working. Everything seems to be perfect. So now it is time for us to check the OpenWhisk package for CloudEnd. So this comes with a lot of actions. So if you see, there are a lot of actions. One of the action that we are very interested in is actually called as the read action, which is this. So this is going to read from the latest document that is added to the collection. It also comes with some of the feeds. This feed is containing some triggers. So we are going to also use this. So this is going to be the trigger for the database change feed, which means when we track this, it is going to fire every time the database is changed. So we are interested in two things. One is this feed, and the other one is the read action, right? So we have everything in place. So let's see if OpenWhisk can talk to this. So I'm going to do a package refresh to make sure that OpenWhisk has access to the newly created sales DB. So finally, when I do a list, it shows us two different packages in our account, in our namespace. One is the weather one that we created in the previous demo, and now we have the sales DB that is all set to get integrated with OpenWhisk. Awesome. So let's now create a trigger, right? And what is a trigger? A trigger is nothing but a channel for the action to get invoked. So we are going to create a trigger from the changes feed. That means this is going to be triggered every time there is a change to the sales DB. So that's what we are interested in. So when we run this command, we are basically saying OpenWhisk that go ahead and create a trigger that will be fired every time there is data inserted or basically any operation performed to sales. So now this is going to be created. Perfect. So now we have a trigger in place that's going to be fired every time there is a new record, right? So let's log every order. So I want to show you a very simple function, right? So here we have a function, and this function does nothing but sends a message, sends an output that says order worth so many dollars is closed by this manager. Pretty straightforward. It's a very simple Node.js function. So what we'll do now is go ahead and create that order. It is nothing different from the hello world that we created earlier, except that we are now associating this action with the code snippet called order.js. Perfect. So now we have an action called order. Let's check this action. So I'm going to now invoke it with synchronous by giving blocking result. Order worth is $10,000. Manager is Johnny. So let's go ahead and execute this action. Perfect. So it is now telling us order worth 10,000 is closed by Johnny. This is exactly what I wanted to see. That means our action is configured the right way. Now what we're going to do is to take advantage of the sequence and create a sequence of two different actions. What are those actions? The first action is the read action from the Cloud package, because this is going to be fired every time there is this is going to pick the latest document from the collection and feed that into order. So basically it is going to input the parameters called order and name into the action that we created in the previous step, order. So we are now creating a sequence called order sequence, and this is where we are taking advantage of the Bluemix Cloud Functions capability of creating sequence. Perfect. So now we have gone ahead and created a new sequence. So at this point, if you do action list, we'll actually see, forget about hello that was created in the previous one, but now there is order sequence, right? And this is coming from this is what we created just now, and then there is order. So this is the previous action that we created. So and this sequence action was from the previous demo. So these are the two things that we are more concerned about. So the order sequence and order. So they represent the actions that we just created. Perfect. So now, how do we tell Cloud to basically invoke the order sequence every time there is new data? So we have to pair them up. So how do we pair them? By creating what is called as a rule. So now I'm creating a rule called log order. And remember, a rule is a one-to-one mapping between a trigger and an action. And the action that we created is the order sequence, which is nothing but a piped action from database read to log order. So every time there is data inserted, this is going to be invoked. And we're going to call this as log order. Perfect. So we have gone ahead and connected all the dots. So which means we have created everything that is required to trigger this when a new record is added. So we'll also enable this rule. If this is not enabled, then it is not going to be fired. So what I'll do now is, in the other window, I'm going to run this command called activation poll. So this is going to keep an eye on the activation log. So we'll leave this as is, come back, and it's time for us to give it a shot. Let's go ahead and insert a new document. So now I'm creating an order in Cloud End by calling the REST API. The order value is 12,000. Manager's name is Janakiram. So when I actually execute this, what will happen? The data inserted trigger will be fired, and it will ask the rule, what are the actions I'm supposed to invoke? And the rule will say you got to invoke the order sequence. And the order sequence will get invoked, which has the database read action, whose output will go into log order. So finally, we should be able to see a message coming out. So now let's go to this. Excellent. Okay, now you will see a lot of action here in the polling window, right? So it has executed a lot of things. So basically, this is the order activation, this is the read activation, and this is the order sequence activation, and it all started from the data inserted trigger. So now we'll use something that we are already familiar with, which is to get the activation list. So when we get the activation list, we should be able to see the most recent one. So let's get the order activation list. So WSK activation result, and this shows us what we want to see, which is basically logging every change. This is just perfect. So which means every time data is added, we are going to invoke this action and the output is going to be sent. So whoever invokes will automatically get that output, whoever is subscribed. So you can do anything that you want. In our case, we are just printing it out on the console, but you can basically put that in another log file or another database or another logging mechanism like an ELK stack. It is completely up to you on what you want to do with it. But that's not all. Remember, our scenario is to read this, and if the order value is higher, send out an email. So now let's go ahead and repeat these steps, but with the other rule, which is basically send out only if we have the order value more than a specific amount. So for that, I want to show you a new action. So this is actually an action that is used for the Sendgrid API. So here you will notice that I'm actually sending it from my own email ID to another email ID with the Sendgrid API key. So you can go ahead and sign up with Sendgrid to grab your API key, and once you have that, you can programmatically send out an email. So if the order value is less than 10,000, we only print low value order, and we don't really send out a mail. But if it is more than 10,000, we go ahead and send out an email to the address that is mentioned here. So let's repeat these steps. What we're going to do now is basically finish this step, notify high value order, right? So it all starts by creating the action. So now I'm going to create this action called high value order, and this is going to create the action. It is not associated with any trigger, any rule at this point. And then if you want to really test this, you can run this command. So we are now trying to invoke the high value order action with manual parameters. So the 10,000 value is not going to go through our rule, so obviously it is going to get dropped. So when we run this, it is going to show us message sent. Okay, so okay, I didn't really fix that, but it should actually, okay, so yeah, this is it is not less than 10,000, it's exactly 10,000. So we should now get an email. So when I come back here and when I look at this, so it shows that, you know, because it is 10,000, high value order worth 10,000 is closed by Johnny. This is perfect. So we are now seeing this working. I can actually change this, right? For example, I can make this 20,000. I can come back and basically update my action. So this time when we send out the same parameters, for example 10,000, it prints low value order, right? Because it doesn't go through the whole process. We are prematurely returning the output if it is less than 20,000. Now everything looks perfect. So let's go ahead and finish the other steps. So what we'll now do is create the same sequence. So we'll again create a sequence called high value order sequence, and it is going to read the database, feed that into the action that we created previously called high value order. So we are now creating a sequence all over again. And then obviously we have to associate that with the trigger. So now we are creating a new trigger called log high value order, and mapping the data inserted trigger from the very first step with the most recent action, which is sending the high value order sequence. Okay, so we also need to actually enable this. So we will enable the high value order rule. Okay, perfect. Now it's time for us to, basically test if everything is working. So we will go ahead and execute this command, which is going to insert a record into our sales DB. And this order value, right, is 50,000. So that means the email should go out. So when I execute this, the record is inserted. You can come back to Bluemix and take a look at the record here. So obviously there are two. So if you take a look at the first one, it is 12,000. The most recent one is 50,000. So it looks good. Now we should also see an email, and there we go. So here we get an email, high value order worth 50,000 closed by Jankira. Perfect. Okay. And it is also visible from the activation poll that we are doing here, right? So if you come back, do a WSK activation list, it shows us a laundry list of all the invocations. So grab the most recent one, right? The high value order. So activation result followed by this, it shows us message sent. This is the output of the function. So we have now created a more realistic system, which is going to send out an email every time a high value order is logged, right? So let's give it another shot. So I'm going to create, let's say we are closing a very high value order, $75,000 by a sales guy called John Doe. So let's try this. John Doe is now closing a sale of $75,000. Perfect. So will we get another email? Yes, there we go. And here it is. Now this is closed by John Doe. Perfect. So this is a more realistic and a meaningful implementation of a serverless function. So it's very interesting. You are actually getting to see everything end to end when you are running the WSK poll activation. So you can see the entire log. At the same time, we have all the actions that are available here, both the independent actions and the sequences that we have gone ahead and created. So that pretty much covers everything that I wanted to show you. And if you are interested in grabbing the commands for this and the source code, you can access this GitHub repo. This is going to be, it's available immediately for you to try. So go to IBM Cloud Functions with Cloud and Tutorial. Basically, all the commands that I have run in this session are available for you to try out. So you can very easily repeat all these steps. And very soon, there is going to be an article published with the step-by-step guide and explanation. Most likely, it's going to be made available at the news stack. I will update the link on the GitHub repo once it is ready. So here is the GitHub repo. So that's not all. As I do every time. I have a request. Please take a second and respond to the poll. It's very, very important for us. I appreciate if everyone participates in the poll. I only see 50% of you participating. Really appreciate if everyone takes a second and clicks on the radio button to tell us what you felt about the session. Okay. All right. I see some more people reluctant to participate in the poll. I really appreciate the feedback, but I'm going to bring up the last poll, which is a direct reflection of my delivery skills and the content. So please tell us what you felt about this session. I see only few of you are participating in the poll. Appreciate everyone participating and telling us what you felt about this session. All right. All right, thank you. So there are a couple of questions. Will the transcript of the session be made available? Well, not exactly a transcript, but as I mentioned, watch this GitHub repo for updates. And this is going to be updated with a link to the tutorial that will be published later this week. The slides will be uploaded to SlideShare, and I'll update the link as well. So the entire tutorial is already made available on GitHub. So I hope that answers your questions. So thanks again for joining me for the TechTalk webinar series. I'm committed to bring you high quality content and cutting edge technologies. The next webinar will be most likely on Internet of Things, where I actually connect real world scenario, real world devices to build an end-to-end scenario. So do stay tuned. I'm going to send out a follow-up email to all of you. Thanks again for attending. Have a great festive season, and I'll see you for the next webinar.